Uh, it's panicking at the expected prim-up value in CodeGen.
Okay.
So I
So
guess
yeah,
I'll send it to you and see if you've seen it before, and if not, then I'll just make an issue.
No, I haven't seen it prim up. I would just open it as an issue.
Yep.
And yeah, Paul, so we don't have to post any of the intermediates, just post the Erlang file.
Yeah.
I mean, as long as you're using latest, he probably has it. So we don't have to post the Erlang file, really.
Yeah, it's just the rand. I guess I could try to minimize it and find exactly which function it is. That might help.
Well, I guess before you post it, is Lumen using the version of EIR you're using?
Yes.
Okay.
Yeah, it's making it past where it stopped before.
Okay. So then, yeah, I would say just do that. I don't know.
Let me just look at it a little bit first and see if I can roughly figure out what it is.
Hey, Paul.
Okay.
Hey.
So I have backtraces pretty well implemented.
That's cool.
And the garbage collection stuff is still in progress, but coming along pretty well.
All you need from me is for me to set the signal, right?
So, I'm sorry. Just trying to remember this again.
So if once I create a heap, anytime I create a heap,
for the garbage collector, if an allocation fails while you're in the runtime, try and allocate a heap fragment and use that.
And then once I create a heap fragment, signal.
Panic.
But if I create a heap fragment, do process signal garbage collect, right? So that the heap fragment gets integrated into the heap as soon as possible. Okay.
And I'm hitting an issue now where, calls to like function calls when they're being lowered. It's trying to like callee new. That seems to only handle the case where the callee is an actual like capture prim up. But then there's also the case of calling a lambda, which doesn't seem to be handled here.
Yeah, I guess I haven't done fun tests on any of my Erlang tests yet.
Yes, statically resolved calls are the only ones lowered right now, and that's mostly just because I haven't gotten around to adding in the pieces for like completely opaque.
So is it worth me actually creating an issue for this, or it seems like you already know about
we want to create an issue just so that the community doesn't reopen issues we already know about.
Oh yeah, sure. I'll make one then just for cracking it.
Yeah, so that's something that's I haven't bothered finishing up just because there's been other things that need to get done first. While we're working within a single module, we pretty much always have the ability to statically resolve those calls, unless we write code to like try and hide it. But yeah, that's a pretty important thing to wrap up.
Yeah, well, I'll just make an issue for it now, so we don't get duplicates.
Yeah. The backtrace stuff, I probably won't be able to work on anything today now, but
That's fine.
Probably tomorrow I'll wrap up the backtrace pieces, which tie into some of the groundwork I did for the garbage collector. I was doing some research on some of the garbage collection stuff before I committed to it, so I finished that up like 2 days ago, and just need to pick up where I left off on that. main thing I wanted to figure out was whether or not there were going to be any issues that fell out of taking advantage of those intrinsics. And it doesn't seem like there are, but there are some. I do have to be careful about how I lower certain things. So I got that all figured out, but that'll require some changes to the code generator to support that. Basically, anything around calls is affected, and the way I lower box terms in order to get the GC roots tracked. I've got all that pretty well sorted out, but it's just making sure that those things play nicely with what LVM uses to not only optimize but reason about what happens to roots as optimizations or transforms are done on the IR. So the nice thing is that basically the support for that works as long as there's stack map support for the architecture. And stack maps, at least on my copy of things, I have support implemented for all platforms, at least in the format. The only thing that's missing for WebAssembly is in the WebAssembly code generator. They don't emit the stack maps right now. And what I need to do on that end is figure out whether or not there's significant differences in how I have to generate code for that. One of the changes that's happening right now in the GC state point stuff that seems like it's pretty close to finished or being finished up is being able to lower GC roots basically in virtual registers, which is what WebAssembly uses to manage where things live on the stack and whatnot. So the nice thing there is that
so when you're writing LLVM for WebAssembly, you're not actually doing like get local, you're just doing virtual registers, and LLVM translates it to like local.kit and stuff like that?
I mean, SSA is essentially just like virtual registers in general, but internally in LLVM, virtual registers are used to essentially represent things that could be in registers, but the register allocator hasn't decided yet. So when transforms are being performed, they're all done, on that virtual register format, and then things ultimately get allocated either into registers or spilled to the stack. For WebAssembly, since everything technically lives on the stack, the virtual registers are just basically used for optimizations. But the main thing is that the stack map format, if it plays nicely, or the GC state point stuff, if it plays nicely with things living in virtual registers, it means that when generating the actual WebAssembly IR, we can track those roots and generate code to actually give us a pointer that we can use. The main thing with that is that it's necessary to be able to identify a function that you're in when you call the GC based on the return address for the call. So at each point where you call runtime function that may potentially GC a safe point, basically, the return address for that call is how you identify what is live at that point, at that call. And WebAssembly things work a little bit differently though. There's not a return address that's accessible. However, I'm pretty sure, and I haven't verified this, there's got to be a way that that same concept is encoded in WebAssembly. It might not be. And if it's not, then I need to figure out an alternative way to encode that and then make that part of the WebAssembly code generator so that we can support that. The alternative is if WebAssembly provides support, natively for giving like tracking GC roots, and giving us those roots at a particular call site, then we can take advantage of that. You know, we don't need stack maps in that case. But
I mean,
as it stands right now, neither of those is 100% the case.
The Rust WASM panic shows the Rust WASM function names, assuming that that is generated in Rust and not. I don't think it's triggered something the browser is doing because of the way it's printed. So I feel like Rust WASM knows which function you're in somehow. So however they're doing it might work for that if it's not in LLVM, but I don't know.
Yeah, I think that's actually the source map stuff, the Dorf debugging information.
No, this worked like over a year ago. The panic looked that way, and that was before the dwarf sort was in.
Right, but what they did for that is they essentially mapped those calls to some metadata that the browsers understand. I can't remember off the top of my head what was going on there. But I mean, like back last summer when I was playing around with exceptions, you know, I was seeing the same thing. I could even step through code and know where I was, but you couldn't access any of like the locals or anything. And I imagine that's probably still true, but that's one of the things changing with the introduction of actual debug info support in the browsers, which I actually don't know off the top of my head where that sits today.
They actually tomorrow's the meeting. I go to it. They're mostly working on it. It mostly works, I think. Obviously, it working in Rust, like no one from Rust is in there, so like it works at the LLVM level, but it might be again where like Rust WASM, it doesn't, like the same problem we had where like it did not put the format correctly for a while, where it was second binary.
Yeah, I mean, my understanding is that basically Rust doesn't need to do anything special for that. They emit Dorf and pass all the correct flags to LLVM to have it generate things for each target. So in the case of WebAssembly, it really boils down to the WebAssembly backend in LLVM.
Yeah. So then the debugging subgroup, I know like the last meeting or the meeting before that, they did update links of like where, for all the different tool chains, where everyone is with supporting it. So we probably can scour their repo or subdirectory, I forget what it is, to check what should work. About the backtraces, I'm already getting backtraces on my test. It's just like the file, it's not the line number. Are you saying you're adding the line number information? Because it already tells what function is blowing up on my integration tests.
I mean, what kind of backtraces are you talking about?
Like it says the Erlang function names. That already works.
Oh, yeah, no, you'll get that in a Rust backtrace, sure.
Okay.
But that's not the kind of backtraces we're planning to show.
Oh, you mean literally supporting
actual
backtrace in Erlang? Okay.
Like, right, not only just the Erlang format for stack traces, but being able to print a trace that's Erlang form.
Okay.
Like better than the way that Erlang does it by default. I was actually looking at the way Erlang prints stack traces, and it's pretty much garbage.
Yeah, they weirdly privilege the first function because you can see the arguments and you can't see it for anyone else.
Right, which is fine, but it's also kind of interesting how much more information you generally get in other languages. And actually something that we can probably do better, because one of the things we also have when we're capturing traces is the ability to combine them with the stack maps to be able to access values at particular points on the stack. We just need a way to identify what those are. So it'd be possible for us, for example, to show what the arguments are at each frame. I guess the question is, yeah, we don't really do any mutations, so that would be definitely viable.
The other thing would be is that a breaking change, because like git stack trace does tell you the format to expect. So like, I don't know if we can add stuff to it without breaking it. Like we could print it differently, but I don't know if we can actually return it differently.
I'm talking about printing.
Okay.
Yeah, not the actual like Erlang term, like that. Yeah, too much depends on that. But as far as printing them goes, like we can do whatever we want there. Um, the thing I haven't really like bothered to try and figure out is, you know, at what point would we do that? You know, the way that I'm structuring it right now is that when the actual stack trace is fully constructed, like we get the Erlang term, then at that point, the object is something that's basically living on the global heap. It's not associated with the particular process. There's a variety of reasons for that. But at that point, allocate a fragment that's also associated to that trace object. And on that is where all the Erlang term stuff gets allocated. So when that exception object ultimately gets freed, then all of it gets freed. But that lives basically independently. We can pretty much pass that around wherever. The main obstacle is, you know, how to reify that from the original trace. So there's some tricks we could use to make that work, but for now I'm basically, you know, only relying on the fact that we have the two primitives for capturing and constructing traces. And, you know, once you've construct the Erlang term format, and that object gets dropped, then all of it gets collected. So at some point, probably would store that maybe in a resource or something, so it could be passed around, or maybe would store some extra metadata in that structure so that we can find the actual trace object from like the Erlang term. There's a variety of different ways we could handle that, I guess. But I think it would be valuable to print the traces using the richer metadata we have than just what's present in that Erlang data structure.
Yeah, I think it falls under the same thing of if we can, that when we actually print the output, we show our anyhow errors too, because then we can tell people which argument is bad. Maybe we do a small syntax extension and like have some way that they can capture it in code later on. But for now, I would just say that we just print it.
So the one thing to note is that in the stack trace itself, the fourth element of each frame, that tuple, is a keyword list. We can extend that probably without breaking anything.
Maybe. So the one thing I have where like people might have hard coded it as a specifically ordered list, because I know this came up in Elixir with extending the metadata, is that it turned out people were exact matching the metadata for the quoted form and not like looking at it as a keyword list. And so like adding extra keys was not allowed in the default format. And so the formatter uses a special flag to add extra keys, like column, which isn't in the default one. Because
yeah, might be one of those things where it's worth it to see if anything breaks.
yeah, and we always, since Jose said he'd help us if necessary, like we could do, what are they called in Erlang? Is it EAPs? You know, where we ask for an extension,
right?
or like this is supported in the stack frame.
Yeah, it would definitely be maybe worth it to at least add to the documentation that the format of that list cannot be precisely relied on. I mean, you're technically not supposed to be relying on the order of those lists anyways, but because they're keyword lists. But if
The way
people are
that
doing
the
that,
type is
then
given. Yeah, it's definitely described as if both keys should be there, because like I have an open bug that we don't do file inline right now, and we should. But
yeah, I mean, the presence of those keys being required certainly makes sense. I don't think that's necessarily a problem. It's more the fact that if anybody's written code that expects that the list is exactly those elements in exactly that order, which would be very strange. Honestly, if it's not present in the standard library, I would assume that probably nothing depends on that precise format for stack traces. But we would have to check. There's a few tools in the community that probably play with stack traces. You know, Elixir looks at them. I don't think Elixir would ever have code in it that depends on the format like that, but you know, Jose is hypersensitive to things that can break Elixir easily, so that would be an obvious source of problems like that. But I'm not sure what else to look at to say, you know, okay, we probably can rely on this, and if there's any community code that's broken, we just open a PR to fix it or something, you know.
Yeah.
Honestly, I'd rather take that approach than be like, oh, this one library depends on the format. We're gonna fuck everybody else's programs as a result, you know. Unless there's like some specific reason why it has to be written that way, you know. But in the meantime, like that's not super important. It's just something that I was thinking about since I already basically had the access to all that information. I was like, I wonder if I should, you know, at least start storing it in such a way that we can access that trace. But I don't know if I'll bother doing that. In any case, trying to think. Aside from those two major things, the garbage collection and the back traces, I still have some outstanding things I need to address, but I'll probably wait until I finish these other two things because they're more
What about
important.
what about the spawning issue where like do you want to when we do a spawn monitor, do we want to do it all in the scheduler where like we have a different where it does equivalent of calling apply to and we set up the registers for the two arguments for apply to in the new process, or do you want to code gen differently the entry point for like for those? What were you thinking of doing for that?
So the main problem I have is that the way that the current spawn and like live lumen OTP works, or let's say spawn monitor because that's more the issue at the moment, is that it does not call into the scheduler to do any sort of setup. It assumes that it does everything.
Well, that's fine. I'm already fine with that. I'm just saying that, like, are you going to code gen anything differently? Or if I made the change, is it okay to do the equivalent of call apply to? Or because you're sometimes inlining the functions, it wouldn't always be an apply to?
I mean,
Or apply, yeah.
yeah, it's basically, look at how I did spawn closure and the minimal runtime. That's basically how that is intended to work. It's essentially apply to.
Okay.
And it's
So
fine to wrap those things in apply to the, yeah, that's fine.
Okay.
Ultimately, all that matters is that we at least let the scheduler set up the process. And
that's
we
fine.
feed it the function that will be the entry point in that new process. So if that is applied, that's fine. The scheduler needs to do a bunch of stuff with those processes to set them up properly, and that was the main obstacle.
Mostly because like spawn is, because the whole point of spawn monitor is that the monitoring happens even if the child process is going to fail. So like, it's not to think that spawn monitor is the one. Is technically spawn opt4 is the megalith. So like the spawn function actually does like should it be linked and should it be monitored, and it does that all at once. And I'm just trying to figure out what specifically should be in the scheduler, but I forgot that you had written spawn closure, and I could just look at that. So I will do that after I finish the GC signaling. So like my status for that is everything is updated to create heap fragments, set the signal, and panic. It was mostly just the process calls. Now, like if they fail doing it on the process heap, it then just goes and makes a heap fragment, and then it if the heap fragment one, since that's still going to give an alloc, if that has an error, it does the panic. Otherwise, it just attaches the fragment and sets the signal for those. So like, there's a lot of code, but it's very boilerplatey. There's probably another pass we can do later with cleaning some of it up, because like the heap fragment ones have to pre-calculate the size, which the process ones don't. So like there's prefix code that is shared between the term alloc implementation and the heap fragment ones now, which isn't great, but we can fix that later. And everything is passing except for one of the integration tests, and that was just because the unimplement in built-in receive done, which I can do now because of the heap fragment thing. It's not an issue anymore. And then I was just double checking my mental model. Heap fragment terms on a heap fragment can point to terms in a process. They don't have to completely live in the heap fragment, right? Or do I need to clone everything into the heap fragment for the DC to work?
They should be able to refer to things on the process heap, yes.
Okay, and then if after the fact, for some weird reason, if like something is too big and so it creates a heap fragment, but then a smaller thing can fit on the process heap, can it point to the heap fragment that points back, like all those sort of links will work? Or is it only heap fragment can point into process heap? Because I don't know how to prevent the other one of process points to heap fragment, because I would have to check that the term is on a fragment first.
No, it's fine.
Okay, that's what I thought. I was just
refer to the fragment, but the fragment should probably not refer to the heap. The reason being that we want to be able to do the GC pass in such a way that we can look at one or the other as like a younger version of the heap, younger generation. So we just need to pick a direction. The point being that we really only want pointers going one way.
Okay,
otherwise it gets a little tricky.
We won't have that guarantee then, unless in the ones I currently run, I would have to do it where I would have to like recursively clone to heap if I need a heap fragment then.
I mean, I think it is worth adding special support to make it work. I just need to think through it and try and figure out the best way to make that happen. Because I think given that is a fallback usage pattern, it's not like we're going to be generating a bunch of heap fragments before a garbage collection happens, probably one or two tops. But given that's going to happen quite frequently, making sure that the collector handles that seamlessly is pretty important. I think probably the best way to manage that would be to do a pass at the very beginning that treats the heap fragment like both as roots and as things that need to be cloned first to the old generation or into the new young generation, depending on whether it's a minor or full collection.
Right, because our heaps support pointer checks. So like even if we had the process heap points to a bigger thing on the heap fragment and then that points down, you technically can always check the pointer on the process heap. Does it point to an off heap fragment? And then intrusive list, you can find out which specific fragment it's on. So you can detect. That's a problem. You just have to know to check for it.
Yeah, exactly. And I don't think heap fragments right now, I'd have to double check what the order of events is, but I think we essentially just treat it as an extension of the current young generation. And when doing a collection, because there's heap fragments, it means that we probably didn't have enough heap space, so we're probably always doing a full collection in those cases. So it's gonna be that, we just probably copy everything into that young generation as long as there's a root pointing to it. Mm-hmm. All this is irrelevant if there's no roots pointing to terms on that fragment.
And then so when looking at the built-in receive done, I forgot that it works this way, but the the messages that are heap fragments are already on the process's off heap, like they're not floating free. And so when we GC, every heap fragment message has to count as a potential root, even if the process doesn't own it yet. Because it might be
You're
live
talking
to
about
scan
messages
again.
specifically?
Yeah. Yeah. Like everything in the mailbox has to count as a root.
Sure, that makes sense. Yeah, just like the process dictionary and
Yeah,
other
I hadn't thought about that
sources
because I
of
knew we did process dictionary already for like the old GC, but I'm like, oh, right, the mailbox needs to too because those can't go away. This is mostly the message ones, though, are different in that they should be self-contained because I specifically know that a message, if it's a fragment message, it is coming from a different process, and that is
Right,
like recursively cloned because the process might go away that's pointing to.
right.
It's just that these heap fragments where the process is making one for itself will potentially have those like comeback links if for some reason you can fit a tiny bit, like 2 words, but you try to make a 4-word thing, then you could still make a 2-word thing pointing to it later, and it would allocate it without complaining.
Yeah, I suspect that we don't have to change much to the way that stuff works now. Just probably a couple small tweaks to account for the fact that we might have bidirectional pointers in the fragment, in the fragment and the process heap, just to make sure that we don't end up with any weird behavior there.
Yeah, I mean, the move markers will work inside of a heap fragment. So in theory, you can do all the move markers, and as long as you don't actually reap the heap fragment itself and like disconnect it from the off heap, it's probably okay. Like as long as you do that last, as long as you don't immediately disconnect the off fragment as soon as you think you do the move, because you might still be pointing to it and have to follow it in.
Yeah, I mean, I don't think any of the fragments get cleaned up until all of the objects have been moved off of them.
Okay, then it might just work then.
The thing is, though, we might be currently assuming that the fragment is standalone, and so move everything on them onto the new heap.
Oh yeah, if we don't leave a move marker,
drop the fragments and then do it. But
okay.
But that's the only thing that I really want to verify there. Okay. Is how we're dealing with that. That's easy enough to change.
And my change will still go in because right now I'm just going to be creating vast amounts of memory and no GC will happen until your change happens. So like it will be a non-breaking change even if this is a problem.
Yeah, I mean, on the reason why I realized I needed to deal with this sooner rather than later was that just in my tests, a lot of the failures that I was seeing, or that I have a few cases, ones that you're reporting, were because none was returned because the term allocation failed, and so in order to at least get past that and not have that noise, having the GC integrated seems pretty important, especially if we're expecting people to start using this, because any non-trivial program is definitely going to blow that heap, no problem.
Yeah.
The one thing that really annoys me that I found out when I was putting together the backtrace stuff is that Erlang trace uses character lists for the path.
Yeah.
And it's just an absurd waste of memory for paths. It's crazy.
So I guess the way I implemented it for the scheduler was I have a trace object, and like I only termify it if I needed it. If like I wanted to.
That's how all this works. But the problem is you're still having to allocate a term that's way bigger than it needs to be.
Yeah, and it also weirded me out because I'm like, you're stat tracing when you're potentially out of memory, and now we're going to create this big bulky thing. Because if it was just binaries, I could have pointed to the pre-existing strings, but I can't do that with it being a care list.
Yeah, it definitely annoys me. That's one thing that I would love to open a proposal for, but I kind of doubt will ever change at this stage.
Mm-hmm.
because it's got to be. I mean, man, I can't even imagine why that. The only reason that I can imagine that was the choice made is because binaries weren't implemented back then.
I mean,
But
I mean, Erlang strings are careless, and like so they think about them that way. I mean, it
yeah, but
makes
they're
sense. You're
also
not doing
aware that they're
UTF-8.
wasteful, which is why binaries exist.
Yeah,
It's just that it's more of a legacy because Erlang in the first like several releases didn't have any form of binary whatsoever. And then once that was added in, too much legacy was already in place. I'm still kind of surprised that they never went back and said, okay, we're going to make this switch, but maybe they just don't consider it important enough.
yeah,
But just looking at the difference in size, like let's say your maximum path length that you'll print in that trace is like 120 characters. Well, it's a difference between 120 bytes and 120 times 8.
yeah,
And
yeah.
that's
Because
it.
it's
I mean, it's even more than that, but
because
not by much.
each cons is a double word.
Yeah.
Yeah,
So it's pretty gross that that's the case, but it is what it is.
yeah.
So I'm trying to think. I haven't caught up on recent bugs that have been reported. Are there any that are notably different?
There was only 2, and I posted them all to Lumen. Let me just review for the video. I mean, the big one we already said was a GC issue, so we already know how to resolve that one. There's the comparing a parameter to the byte size of another parameter says the branch has operand 0. You said it might be cogen.
Right, yeah.
It was when I was what was I doing in that test? Oh, when I'm like trying different sizes of binaries for stuff. So I'm kind of like recursively varying the size of a binary. I'm using byte size as the termination condition to stop growing it or shrinking it, and that it doesn't work as a function clause guard. It works as a case though.
Oh, interesting.
Yeah.
Well, I think I know at least what the deal is there. There's a few places that had code gen that I hadn't fixed. It'd been basically written once and not changed.
Mhm.
And so that's where a bunch of those bug fixes came from. This one I haven't looked at yet. I got to double check that, but I'm sure it's something super dumb.
Yeah. And that's like the only new bug I think. Yeah. Because the empty binary literal was, oh no, that was since the last meeting. And then there's like 2, like whenever we get into parsing floats or integers, like we don't link correctly somehow. And that's a Rust bug with why the build is picking the wrong version of the trait libraries.
So it's, oh, right. Yeah, I need to double check how liblumen OTP is linking. I don't think it's being linked like the other crates.
There's no build RS for it. It just does whatever's default, which means it's picking the wrong one probably.
Wasn't it doing something like referencing the runtime crate or something? Or am I thinking something else?
It does that only for the ones that still use full. In the actual integration test, it shouldn't be because it's set as a dev dependency. So like for the build that the integration test used, that's not true. Or that's at least
have you tried just like building the compiler and running that specific test case through it outside of the test harness, like as a standalone program? I'm curious if it is
I should try again.
effect of doing the build as part of the test suite, or
yeah, it could be because that's usually how this happens. Where we get 2 copies of the library, is the test for whatever reason builds another copy with a different hash.
Basically, the key there is to make sure that the search path for each specific library is in a place that either we've guaranteed is unique because we set it up that directory to be that way, or includes information. And that's why a lot of those crates have build scripts, actually, is because that's how I propagate some of that info. But I haven't gotten a chance to look at where specifically that case is going wrong. I'm sure it's something that can be fixed, though.
Mm-hmm.
If not, then probably what it means is that we'll have to, I don't know. Yeah, we just have to change our approach for how we're building that and linking against it. The key thing we need to make sure we're never doing is, linking two different builds together. We want all the artifacts to be from the same build,
But
which is definitely awkward with the setup. But
without using the build RS, we're definitely not using the make build puts the the finished stuff under bin, and we're definitely not using that if we're not using a build script. So
right,
there is that problem. I mean, liblumen otp.lib gets put there after the make build is done, but obviously by that point it's already potentially linking against the wrong version anyway.
Although
Although
maybe not necessarily.
Yeah,
it depends. If it was built against a different version of the Rust libraries because upgrade happened or something, then yes, potentially you could have that linked against something else. If
no, because I've done
copy.
make clean and it does it fine. But I mean, it still triggers a make clean, so there shouldn't be more than one copy that way with the wrong Rust version.
Right, I'm saying that the version that's in that directory is going to be the static archive of liblumen OTP. It won't contain any other objects, but it will expect that symbols it needs get linked in. And so the thing we have to verify is it built against somehow a different set of Rust libraries. And the way that we're currently figuring out what Rust libraries to grab is by finding the Rust root and grabbing the static versions of those core libraries from there, libcore and libstandard, and then linking against those when we build the executable, the Lumen, the Lumen generated executable links against those. But if liblumen OTP somehow linked against a different version of those, in that case, then at link time, those symbols won't be present and it'll complain that they're missing. And that might be what's going on there. I don't know. The linker gets kind of weird sometimes. The other thing we have to make sure is that we link things in the correct order. So if the order of the crates is not just right, then the symbols that fulfill the requirements of liblumen OTP, if they're already linked, it's going to think that they're not present.
Well, that feels weird though, because it's just the math parsing ones that are different. It's just number parsing. It's integer and float parsing from.
And is that stuff that's in the num crates or something that's part of lib?
They're in core. There is even about core. That's the weird thing. I'm the rest of core is there. How are these ones that are off? The only thing I can think of is that there is some flag that changes that hash when it computes the actual symbol name, and it's some flag is different that affects core.
ID of
that could be it.
It's the type hash of the generic signature.
Yeah, it's
and
it's
so
all related to numbers.
Changes.
Because radix format
code, what is it parsing?
Oh, it's just parsing it should be parsing a string because it's just a byte vector that we want to like either get a float out of or an integer out of. And then for one of them, we use radix format for however it does its parsing, which uses parts of core to allow you to parse in any base you want. And that's how we handle the one where like binary to integer with a base is using radix format.
Yeah, that's interesting. I don't know. I'll have to experiment and try and see if I can replicate that one. But yeah, give it a shot outside the test harness. Like blow away your build, and try it from scratch and see if it happens again.
Mm-hmm.
If it does, then we know for sure that there's something about the way our stuff is getting linked. And if it's not happening, then we'll have to assume that either it was a transient thing or something about how the test build runs that is throwing it off. I could see potentially something with it being the test build. I don't know how this would happen outside of that, but the linking stuff is real arcane. Things can go weird in all sorts of different ways, and it's completely non-obvious sometimes.
So there will be two copies of radix format. They're both using 100, but like core uses radix format. I don't know what for. I'd have to look. But so does OTP. So they're both linking to it in the Rust style. So that could be an issue. Although Rust is supposed to support you linking to both, but then when it somehow gets to the OTP parsing of it, it thinks it can't find it.
When you say linking in the Rust style, what do you mean? The mangled
like
symbol?
It's a cargo dependency. So like it's not a build RS thing.
Right, yeah. So yeah, that actually could very well be the problem there.
Well, that's weird. I can't.
I would have to double check and see if some settings changed. The one thing we have to make sure is that that Rust is not trying to link to the dynamic library.
Oh yeah.
Because it tries to do that in some cases. I'm pretty sure prefer dynamic is not the default though, but I'd need to check. If you dump the actual compiler invocations, you could probably see what the linker flags were.
Looking at this though, I can't see why the core runtime actually has radix format. It's a dependency, but like it's not. There's no reference to use radix format anywhere in the code. So I could get rid of it there and see if it fixes it, but obviously that's an annoying thing. If the runtime can't have the same dependency as OTP without the linking going wrong, that's an annoying problem to have continually. But
so you're saying that code was dead, and so we don't actually need it?
At least for radix format, but there were other ones for where I was using core Rust because like Rust has float parsing built into it, if I remember correctly, and I just used that. Radix format was only used for integers, I think.
Interesting.
Yeah, because there's no reason to have a base parsing for floats. I mean, you can have decimals and weird floats, but it's not a thing Erlang does.
I wonder if maybe the symbol is being treated as dead and not actually pulled in, and that's why like something later on gets linked that expects it to exist, or makes it effectively not dead.
Mm-hmm.
And because it was stripped out either by the linker or by Rust, I don't know what. That's what is causing it to fail. I don't know. I'm sure that it's not like a fundamental issue.
No.
It's just probably just some ordering thing. We can definitely get that sorted.
Yeah.
And honestly, when we're putting together like a packaged version of Lumen, like none of this is relevant anyways, because that package will be self-contained and we'll already know that it works correctly. So
yeah.
We just have to make sure we can produce that package.
And realistically, binary to integer with a base is not a terribly important one for the conference to demo. So I'm not. More importantly, is we get spawning working than like I get binary to integer and binary to float working.
Yeah, I will make sure to get that the calling of closures, basically terms, I guess, not closures. They are closures, but they don't have to be. Get that fixed so that we don't have that as an obstacle. And then you're making the changes to the runtime to support the scheduler handling, the process setup that should address the last kind of outstanding thing on the spawning side, I think. So all that remains then is, making sure that the garbage collection is wired up, and I think we'll at least have a pretty solid, platform to build off of for the conference.
Yeah, the one weirdness we'll have to think about is for export style closures, like where you capture a specific function and then you do apply to and you give it the wrong args. The stack trace in Erlang says you did apply to, but technically we know what function you're going to call, so we could give it that entry point. But then if you give it the wrong set of arguments for apply, it won't blow up the same way. Now,
yeah, we need to validate that closure before we pass it to the generated code.
So if we were going to keep it the way full does, like it would still work as a closure, but you would anything that applies, even if you can do it, if you can apply but you think it's going to blow up, you would export the function in the dispatch table, just so that you could pull the code up and then check the args and go, oh, you're wrong, and blow up in the right way. Even though it doesn't technically need to be exported, it's there you'd have to generate code to error like apply to is being called. I don't know which one is better.
Yeah. I mean, for efficiency reasons, it might be preferable to try and, protect closures before we even call them, but to guarantee the behavior, it probably makes sense to have the generated code that does the closure environment unpacking do that validation.
But for exports there is no closure environment, so it's different. It's just that like if you capture IO puts 1, but you pass it an empty array, and like you do a spawn to do that, it will blow up as an apply to, but in the child process. And like we need to emulate that behavior somehow.
I mean, we could just transparently change it to call a function that just always raises that error.
Yeah.
Since we know ahead of time that the closure is going to blow up.
Well, the other thing is we might still need
closure, Sorry, the function call. We can't make a function call with missing arguments. That's just fundamentally.
Well, no. So like it's applied to checking. So like you would have to. The only problem with apply to is you need to be able to get the arity of. Well, no, you don't need. Actually, no. For when they blow up, you don't need it registered because you just need to know the arity, and the closure already knows that. Like the box closure knows that, so it works fine without an export. So yeah, it would just be if you do it always as an apply to call in the generated code, it'll do the right thing for errors. But when you know it's not going to error, you can skip the apply to because it won't blow up. Because apply to replaces itself, so like you never see the apply to in the stack trace if a call goes through because of the tail call replacement. So just be like when we're not sure it's going to blow up, we need to go through apply to. Like if the args is too opaque for us to reason about that as the right size list, it needs to go through the apply to call so we error.
Right. Yes. Yeah. I mean, we'll always need to do that anyways, because except with statically resolved calls, we don't. But in the case where we don't actually know, or we can't determine that through data flow analysis, then we'll always have to use apply for those. No way around that.
Yeah, I think it's perfectly valid and like a benefit of Lumen that if we can do data flow analysis, figure out that like this will not work, it's fine to be a compiler. We don't have to wait till runtime to tell them they messed up.
Right.
Because like I think it's
Yeah.
a benefit of us.
Definitely. And I'm hoping that especially once we get more type information, we can do a lot better on that front. Right now, we basically don't try and do any real reasoning about the code, but that should be able to change, you know, as soon as we get far enough along here where Hans and I can really dig into that side of things. Probably also need to coordinate with Jose and some of the other people in the community that have been poking around in that area of things to see where things sit. I kind of get the sense that nobody's really bothered looking at it for a while now. But I better get running here.
Okay.
I'll keep you posted. Let me know if you hit any issues, and hopefully by this time next week we'll have that stuff all ready to go.
Mm-hmm.
Anything else from Hans, Brian? No. Cool. All right. See you guys later.